section 8.2, we're going to talk about hypothesis testing, the 4 steps included there, but now we're going to add some more details into these steps. So we've already talked quite in depth about the hypothesize steps. So in that step, we're going to state our hypothesis about the population parameters. So again, remember, our hypotheses are always about the entire population. Okay, so what those look like, remember we have our null hypothesis, our H sub naught, and that will always be P equals some value. Whatever the accepted percentage or proportion has been, we assume that that's what it still is. And then we have our alternative, our H sub A, which is always P is either greater than, less than, or not equal to whatever that accepted value was. So we have to pay attention to the wording of the problem, what we want to use. Are we specifically looking for an increase, decrease, or just a change? Okay, then as we get prepared, we get ready to actually perform our hypothesis test. We always want to make sure that we state our significance level. And remember that the alpha equals 0.05 is the standard level. But we could change that if we wanted to, or you just need to pay attention to what they tell you to set it as. Usually they use 0.05. We want to choose the appropriate test statistic for the hypothesis. Right now, we only know 1, so this seems a little bit like a silly step, but as we move on through the rest of the course, we're going to add more and more possibilities to our list. So right now, we only have Z. The only place we're going is that proportion stats area in StatCrunch. Again, we're going to add more to our list, but right now that's where we want to go. Then we need to state and check any conditions that might be required, and state any assumptions that must be made. So in order for this test statistic to work for us, in order for the Z statistic to work, remember the conditions that we have to meet. We want it to be described, we want the sampling distribution to be described by an approximately standard normal distribution. And if we meet these following conditions, we can assume that's so. So if we have the random samples, the large samples, and big populations, as well as the independence going on there, then we know we're good to proceed. Now, if we don't meet those criteria, we either have to stop, or we have to, at the very least, make a note that maybe we're in a borderline case, so what we come up with after this may not be completely reliable. So we do want to check those conditions. Sometimes they will say assume they're already checked, then you're good to just get going. But if they require you to check them, then you'll need to do that. In the real world, when you're doing your hypothesis testing, you always have to make sure that those are good to go. Okay, step 3 is when we're actually going to compute some values here. So we want to compute the observed value for the test statistic. So again, for us, it's going to be a Z value. We're also going to find the P value that goes along with that in order to measure our level of surprise. Again, both of these values come from StatCrunch for us. And finally, we're going to compare the p-value that we get, our level of surprise, to the alpha value that was preset, and that will help us determine a conclusion. Okay, so once we've determined which extremities we want to use, we can use technology to tell us this p-value. So just as kind of a reminder, your p-values are always shaded regions in the tails, right? So we have a left tail here, right tail here. So this is a two-tailed p-value. This one's only a left tail, and this one over here is only a right tail, but they're all tails. So I know that there's a question in MLP that's like asks which one of these could not possibly be showing a p-value. What could not ever possibly be showing a p-value is something like this being shaded under the curve. right? There's no tail on either or both ends being shaded. It's something in the middle. So this could not be a p-value. P-values are either one tail, the other tail, or both tails. Those are the only options. Okay, so let's recall, we're talking about these p-values there. Let's remind ourselves what is the p-value. So the p-value is the probability. Again, so if the p is a probability, that means it has to come out as something between 0 and 1. The probability that if the null hypothesis is true, that a tested statistic will have a value as extreme or more extreme than what we just observed. So what's the probability that our H0 is true and that we would get some even more extreme value in the future? Okay, so if your P is large, that means there's a large probability that if we took more random samples, we'd get a result even more extreme than what we're already seeing. What that tells us is it's likely that what we've observed will happen again. Hence, what we saw is not very surprising. Right? If whatever we observed, the percentage that we observed is very likely to occur over and over again, then it's not very surprising. It seems pretty typical. However, if you have a small p-value, what that means is that there's a small probability that if you took more and more random samples, that you'd get a result more extreme than what we just saw. So what that tells us, it's what we just observed is very unlikely to happen again. If it's unlikely to happen again, what we saw is very surprising. Okay, then how do we take these values and use that to interpret? Okay, so we take our p-value and that tells us, are we going to reject the null hypothesis or not? If p comes out less than alpha, right? P is small in this case. Smaller than alpha, then we are surprised by what we just saw and we reject the null. We conclude that there is enough evidence to support the alternate claim. So we've provided enough evidence to change our minds. However, if your p-value comes back larger than alpha, if you get a large p, you fail to reject the null. We conclude that there is not enough evidence to support the alternate claim. So as a reminder, again, this is in bold print here. This is super important to understand. Your H0 is the default or the innocence stance, right? This is what we believe unless we can show otherwise. It does not require any evidence. You don't need to show proof of being innocent. You only need to show proof to show a guilty verdict, right? So you never need to write, and you never should write a conclusion statement saying, there was enough evidence to support the null. I don't need evidence to support the null. The null is the default. It is what it is, and it's what we must believe unless there's evidence otherwise. So the null doesn't require any evidence. Be careful because they give you different wordings in MyLabs Plus, and you want to make sure that you're never saying, I need evidence for the null. I only need evidence for an alternate. Then we always follow that up when we decide whether we are or not going to reject. We always follow that up with, well, what does that mean in context, of course. So a few kind of word tricks to help you remember some of these things. I've heard this one before that students really like, where if we say, if the p is low, the null must go, right? So the small p means to reject the null. So that might be a statement that's helpful for you to help you remember what to do. I also am fond of remembering this, that the smaller p gives us a shorter sentence. So anytime we get a p less than alpha, it's going to be weird again. So when p is less than alpha, I use my short sentence. I'm going to reject the null. Short, sweet, to the point. However, if my p is larger than alpha, then I need a longer sentence. I am going to, in this case, fail to reject the null. So whatever way you want to think about it, it's very important for you to remember what to do when your p-value comes out either less than or greater than alpha. Smaller than alpha, reject the null. Larger than alpha, fail to reject.